Hi, my name is Callum, and today we're going to be going through this setup manual for the Arduino data logger. Basically, it's going to be a tutorial based on this manual, which is linked in the description. We're going to be taking through all the components needed, where to get them, how to set it up and attach them to the Arduino, and then go through each kind of setup sketch and set up the data logger program, which is adding the SDI sensors and ensure that they are reading and working properly. All right, so without further ado, let's get right into it. We're just going to go ahead and open the navigation pane here under view and navigation pane just to give us a nice overview of all the area sections that we can view here. We're going to skip the introduction, basically gives us some background information on the Arduinos, the SDI-12 sensors, and some telemetry that we're going to be using. We're going to skip this section just for the sake of time. You can go ahead and read through it, pause the video and read through it if you'd like. But we're going to skip to the data logger components. Alrighty, so the good thing about this data logger is that if your one component fails, you should be able to replace that one component instead of the entire data logger. So before we get started, you should have everything you see on here, each component. Um, so if you don't, please pause the video before proceeding, because I'm just going to assume that you have all this stuff and you won't be able to complete the setup without it. So now that you have all the components, we're going to go ahead and skip to section 3 and assemble the data logger. This is here is the pinout diagram that we're going to be using. It describes all of the connections that we're going to make to each of the modules and the Arduino. We have our real-time clock, the DS3231, the SD card module, and the RS232 input. Basically, this allows us to connect to the modem and use telemetry. The SD card module allows us to store and log the data, and the DS3231 is a real-time clock module that will keep the time even if the Arduino data logger is disconnected from the power there. So basically, this diagram is really good to have with you while we go through the setup in the next section here. So basically, it'd be great to take a picture or screen snip or print this guy out to follow along as we go. So yeah, let's get right into setting up the data logger. Alright, so just before we begin, note that we're not going to be using all the components listed in the manual. We're just going to be using what you see here. So we got the SDI-12 sensors, the Arduino, the screw shield, the Arduino's USB-A cable, a small breadboard, some jumper cables, the DS3231 along with its battery, the SD card module along with the SD card. Note that the SD card is pre-formatted, and we're going to go ahead and assume that you pre-formatted it. The formatting is in the manual, how to do that, so please go ahead and do that before proceeding. So now the setup is done according to the pinout diagram. So we can go ahead and plug that in to the laptop. And as you can see, the lights turn on for the modules and the Arduino, so that means the power is correct. Now we're going to set up the SDI-12 sensor according to the manual given. These are just whatever the manual tells you to do. You set up the pins for the power, ground, and data. Once we have those in correctly, we can now go ahead and look at the setup sketches and begin setting up the data logger. Alright, so to begin, we're going to download and open this file folder here, set up Arduino data logger version 1. This version number should be this in line with the manual, and the link for that should be found in the description or in the manual. We're going to assume that you have already followed the manual to download the Arduino IDE, and you're semi-familiar with that software. So yeah, let's begin the data logger setup. All right, so the next part is the SD card test. We're going to go ahead and open that guy up. Basically, this just will make sure that the SD card can communicate with the Arduino so that we can log the data to it. And we don't need to change anything other than the serial baud and ensure that the chip select is 10. So we can go ahead and upload that. The chip select is the CS pin on the SD card module, and it can be changed around a little bit. Um, and if you're using a different board, you can also change it according to that, but we're going to keep it as 10. So once it is uploaded, we can go ahead and open the serial monitor, and boom. So this menu should pop up if the SD card is communicating with the Arduino and the Arduino is communicating with the SD card. As you can see, our format is FAT32. Please ensure that this is formatted in this way. The SD card is formatted to FAT32, or else it will not be able to communicate with the SD card. The other troubleshooting is that the wiring or the module just isn't working. So yeah, now we know that the SD card is set up, so we can move on to the next part of the actual data logger setup. All right, so we're going to do the set date time. So this is going to be using the DS3231 module, and we're going to set the correct date and time. So just to begin, we want to make sure the serial baud is 9600. And then we're going to come down and edit these guys here. So for this guy, this example is actually not correct to the August 4th. It's actually August 19th at around 1:44 with 25 seconds. Note that you want to try and add around 10 seconds from the actual time to the upload time, just to account for the upload time. So you just want to go ahead and open an actual world clock to get the exact time in seconds. So today is the 23rd of August when I am recording this video, and it is around 3:20. And we also want to subtract an hour just to because we don't account for daylight savings time. So we're going to actually set it for 2 o'clock, which is 14, and it's around 21 minutes. And I'm just going to account for the clock time and set it for 30 seconds. Alrighty, so we can go ahead and upload that. This is the upload, or Control U is also upload. And then once it is uploaded, we shall check the monitor. By hitting this, and then under sketch, no, tools, serial monitor, Control Shift M. I'm going to use the Control Shift M version from now on. And now we can see that the DS3231 is set up correctly and the pinout is correct because it is communicating. So sweet. Now we have our time set. We can move on to the next sketch. All right, so the last sketch that we're going to look at before actually getting into the data logger program is the SDI-12 sensor setup. Basically, this guy is just going to reassign the SDI-12 sensors to different addresses. You don't have to do these for analogs, just the SDI-12 sensors. Please note before you get into this as well that you're going to have to do this for every single sensor individually, and also that all of your sensors and modules and Arduino are all on one common ground, as sensors won't work if they're on different grounds. And it's a surge precaution as well, that your components are protected if there is a surge, that they're all on one good common ground. All right, so the only thing that we have to make sure of this sketch is that the serial baud is 9600 and the data pin is at number 2. You can switch the data pin, but for our pinout layout, we're going to be using pin 2. So we can go ahead and upload that to our Arduino. And then once this is open, it's basically going to check all the addresses of the SDI-12, which is 0 to 9, and then lowercase a to z, and then uppercase a to z. It's just checking all the addresses to figure out where the sensors are. So once that is uploaded, you can go ahead and open it. And this is a new sensor because the default address is 0 for those guys. And we're just going to go ahead and reassign it to number 1. So you just hit 1 and then enter. And please note that the data logger actual program only uses integer values as the sensor addresses. You can use the strings. You're just going to have to, do some of your own modifications to the data logger program. But you only have to really do that if you're using more than 10 sensors, because there are 10 addresses that are available from 0 to 9. All right, so we've done that for our single sensor. And again, just ensure that you do this for every single sensor. Please try and keep them off of this different addresses. Like each sensor should have their own specific address, as well as try and keep a good practice of writing the sensor address directly on the sensor as seen in the manual, just to prevent overlapping again, because there can be some communication errors if there are multiple sensors assigned to a single address. So yeah, that's it for setting up your sensors. We can move on to the next section. All right, so the last setup piece that we have to do is the actual data logger program. So we can go ahead and open that up. You can click on any one of these. These are basically just sub files within the actual main data logger program. And we're gonna actually, before we do the setup, we're gonna go through the data logger program and like look at each kind of uh, subtask and just get a basic foundational knowledge of what's going on within the program before we actually set it up. So each one of these tabs are the files that you saw previously. So this is the SD card functions that are being used in the program. Basically, one takes a file name and a string of text and writes to that specific file name. Another opens a file and reads all the data from that file. Basically, these are used for the SD cards so that we can communicate, locking the data to and taking the data off of the SD card. The SDI-12 function are taking measurements. Basically, we have one to actually take the measurement, and then another function to actually get the value of the measurements that we're wanting. Because the measurements that are taken of this function sort of have a sort of look like this. They'll have a value of a number, and then a plus sign, and then another number, a plus sign, and then another number, a plus sign, and then another number. And these numbers in between the first and the last are the most important, because, or like these guys here, because normally the first is the address and the last is like the amount of measurements I believe it can be taken off of, and then the interior 2 or 3 or 4 or however many measurements allows the SDI sensor to take are like the actual measurements. So for the soil moisture sensor that we're using in this example, the first measurement that we're going to be taking is the volumetric water content, and then the second measurement is the actual soil temperature. So that's going to be these two values. And this get value function basically gets that from this take measurement, and then the measurement output combines those two and also adds the slope and the offset to the reading and outputs it as a float instead of a string. So yeah, that's basically the SDI-12 functions, and they are just taking the measurements and adding the offsets to them. The date time is creating the string of the date time. Basically, it outputs it in the year, month, day, hour, minute, second. If you want to change that, this is where you do it here. You basically, you can change like month, day, year, or however you want it. But that's how you change it in here. You just switch around these guys' parameters. But yeah, and then this function is specifically for Camel Scientific temperature sensors. It's an analog sensor. It takes an analog sensor voltage and an input voltage and calculates the actual temperature using the given formula in the manual. Note that if you're not using a Campbell Scientific temperature sensor, with this exact formula, you will have to add new analog sensor calculations into here. You can either create a new tab and add a function there, or add the function into this section. So yeah, now that we've went through those, we can now get into the actual main section of the data logger setup. All right, so getting into the main section of the data logger code, this is where the actual data logger program takes place, and the measurements are taken at the defined, interval of time. So we're going to go ahead and make sure that all of our parameters are good. Our data pin is 2. Our soil sensor address is number 1, which is good. Our serial baud is 9600, which is good. Ensure that this matches kind of the sensor that you're doing to the address. This will just make it easier um, when push comes to shove for like keeping track of which sensor is taking which measurements on which address and so forth. So original data and the daily data. So we named these test underscore O and test underscore D. Basically, the original data is going to be the cumulative data, like all the data taken from when data logger is put in place and started to accumulate data to present. The daily data is going to be reset every day whenever the data is taken off of the SD card and put into the database. It will reset whenever this daily data is read from. So that's all that. Um, all right, so now we're in the setup loop. So this is the loop that kind of happens prior to the main loop that'll be running at all times. Please ensure that this is coded out unless you need to reinitialize something. Um, because if your data logger is reset and this is uncommented out, this is able to run through this section of code here, and your data logger resets, it will reset all your data again, which is not good, just in case, because you will lose all that data. So please, if you need to remove the data files for whatever reason, please uncomment, upload, and then re-comment this out and re-upload a new set of code. Just because if it is uploaded where this is uncommented like this, then it can run through this whenever the data logger has been reset. So please just keep this uncommented out or commented out, sorry, whenever you're not using it. So yeah. Basically, these are good. Your daily data and original data. There's our time kind of. Sorry, not time. Our our headers for the two data files. And then this is your setting your alarm every hour. So basically, here's your setting your alarm every hour on this minute. So this is where you can change the minutes from 0 to, the first minute of every hour, the 10th minute of every hour, and so on and so forth. We're just going to keep it at 0. So basically, every hour on the 0th minute, the alarm is going to sound, and then we are going to take our measurements and do what we need to do on when that alarm is sounded. So basically, we are going to change the main loop code now. So this is what is going to be continuously running. Basically, we are just going to ensure that all of the variables are correct, all of the headings are correct, all of the measurements are correct. So right off the bat, we can see that this is not what we're measuring. We're measuring volumetric water content and soil temp. I'm just going to name it abbreviated SLTP, soil temp. And this is off of the soil. So yeah, so now we have, these are the two floating variables that are reset every time, it needs to take a new measurement. And yeah, so now we're into the alarm. So whenever this alarm is go off, this string of code will basically fire off. So it is taking the date time and putting it into a string, and then adding the measurements to the string as well. So we need to change these measurements to the proper ones according to the sensor, which is we just defined up here. and it's not on the PT12, it's on the soil sensor address we defined earlier. And our first measurement is the VWC. Our second measurement is the soil temp. These are the two measurements that the soil temperature sensor can do. We don't need any slopes or offsets according to the manual, which is great. And then basically we're just going to add these two to the data string that we want to get outputted into the two files, which is done like this. So now basically this data string includes our date and time, as well as these two measurements, all separated by a tab. And then it writes these data strings to both our files. And that happens every hour on the 0th minute according to our alarm that we set. So now we're going to get into the commands and the outputs for those guys. So basically we have three commands. We have the 111 command, which is a live reading. Basically it just takes exactly what it says it does. It takes a live reading. So we want to take these two measurements that we defined earlier and put them in here. And then we want to change the data string as well to what we defined up here. Simple copy and paste just to make sure. But we also need to realign the actual header that is displayed because it is not HG, it is VWC and the soil temp. Sweet. So now when you take a live reading, it's going to display this header as well as the date and time and the two measurements that we defined. So that's good. So that's the 111 command. That's the live reading command. Next is the 222 command, which basically displays all the data from the original data file, which is the cumulative data. So that's going to be so much data, which is why we created another command to take off the data off the SD card, and it's why we need two files. So the 9999 command is when the daily data is called. So that is all the data since the last reset of the daily data file. So basically, if you haven't taken the data off the data logger in 3 days, there'll be 3 days worth of data. If you take the data logger off every hour, there'll only be 1 hour of data per command, basically. We also want to realign this heading because every time that it is called, uh, it resets the heading and resets the data, right? So we just wanted to make sure that heading is properly aligned with everything. Alrighty, so now all of this is correct. We can go ahead and upload this guy and we will see if it works. All right, so now that we've uploaded the program, we can go ahead and open the serial monitor. And just to make sure it works, we're going to run through the three commands. So 111 is going to take a live reading. So we should see the date, the time, and the two readings that we took off of it. So there we are. There's our date. There's our time. And there's our volumetric water content. It's in air, so this is roughly what the manual says it's supposed to be. And the temperature in the room I'm currently in is around 21, 22 degrees C. So the 222 command should show you the cumulative data, but there is no data, so it should only show the heading. So yeah, there's the heading there for that guy. And then the 999 command, again, should only show you the heading, or the 999 command just show you the heading because yeah, again, we only added the headings. I think it's two headings in there because I added a heading. I might have accidentally uploaded this twice, which means that it wrote the heading twice to it. But yeah, so there we go. We now have a working data logger, which is great. The next test would be come back in an hour and see if it took a proper reading. But other than that, you can go ahead and disconnect this from your laptop and begin to, make it into the remote data logger that you want it to be by adding in your serial to TTL module. I believe it's the RS232 to TTL module that will enable you to connect to the modem and then connect all the other components in as the diagrams in the manual explain. So yeah, I hope you found this very interesting and intuitive, and I hope that it works out for you and that this data logger is a great resource. Thank you.